So hello students, in the last class, in the last two video lessons, I have explained about finding number of divisors, finding even number of divisors, finding odd number of divisors, and how to find out number of divisors of the form 4k plus 1 and 4k plus 2. Right. So in this class we will try to solve these four questions. So if time is too lengthy, if it has become too lengthy, we'll solve one or two questions, and remaining two questions we'll solve the next video lesson. Okay. Now you see the question is this. The first question is you have to find out the sum of divisors of n. Okay. Now you have to watch till to the end to understand this is in a better way, right? Because if I am going to give you the details how we got the formula, then we will solve the problems using that formula, right? So here we have n is equals to 2160, and if you see the canonical form of 2160, what it's going to be, I think 216 is 6 cube sorry, into 10, and 6 is 2 into 3, so 2 cube into 3 cube, right? Into this you can write 10 as 2 into 5. So that too I'll join here, 2 power 4 into 5. So this is the canonical form of 2160. Now first I'll take a simple example to make you understand the formula, how to get the sum of the divisors of a particular number n, right? Now let's say for example simply I take 12, okay, which is 2 square into 3, 4 3 is a 12. Now how many divisors this 12 has? You know how many divisors this 12 has? 2 plus 1. Okay, we have seen this formula in the previous classes. If you want, you can go and check that video. Right, so 2 plus 1 into 1 plus 1, which is 3 into 2, we have 6 divisors. So totally we have 6 divisors for the number 12. Can we write all those divisors? Yes, we can write 1, 2, 2 square, that is 4, then we get 3, then to the 6, and for the 12. You can see 6 divisors we have. Now sum of the divisors means we want to calculate 1 plus 2 plus 4 plus 3, 6. 3 plus 6 plus 12. This is the sum of the divisors. But every time it is not possible to write all the divisors, sum of all list of the divisors, and then we can add. It is a difficult process. Every time we can't do. So instead of that, what we'll do, you see now, related to the prime 2. Okay, related to the first prime 2, what are the divisors you have? 1 comma 2 comma 2 square. Now related to prime 3, what are the divisors you have? 1 comma 3. Okay, the divisors for prime 3, 1 comma 3. And related to the prime 2, what are the divisors of 2 square? 1 2 2 square. Now take just sum of these divisors, 1 plus 2 plus 2 square. Okay, now take the sum of these divisors, 1 plus 3, then you take the product. What will happen, you see now, whenever you do like this, what is the meaning of this? You are adding 1 into 1, you are adding 1 into 3, you are adding 2 into 1, you are adding 2 into 3, you are adding 2 square into 1, you are adding 2 square into 3. What are all that? 1 into 1, 1 you get, then 1 into 3 you get 3, and then you get 2 into 1 2, then you get 2 into 3 6, then you get 2 square into 1 is 4, then 2 square into 4 12. So you are adding all the divisors here. Alright, so what we do, for each prime we write sum of the divisors separately. For each prime we write sum of the divisors separately, then take the product of that, which gives you sum of all the divisors. Now for example, let's say I have a canonical form. Okay, I have a canonical form of a number n is equal to p1 to the power of alpha 1, p2 to the power of alpha 2, like this, pk to the power of alpha k. So this is the canonical form of a number n. Now related to the prime p1, whose power is alpha 1, what are the divisors we will have? The divisor will have 1 p1, p1 square is also a divisor, p1 square, then p1 cube, up to so on p1 to the power of alpha 1. So these are the divisors related to the prime p1. Yes or no? Then you add all these divisors related to p1. What are the divisors you got? Just you add them, right? So if you add them, then similarly you write the sum of the divisors related to the prime p2. into 1 plus p2 plus p2 square plus up to so on p2 to the power of alpha 2. So repeat the same process for each prime. Okay, then you multiply them, you will get sum of all the divisors. If you want, you can check one divisor p1 into p2, that is one of the divisor. P1 square into p2 is one more divisor. P1 square into p2 alpha 2, that is also divisors. So you are going to form all the divisors in this, and you are going to take the sum of that, right? So therefore you are going to get sum of all the divisors. But you see this expression, can you identify this expression? This is sum of geometric progression, sum of alpha 1 plus 1 terms of a geometric progression. How many terms are there? Here you see first term, this is second term, this is third term, this is alpha 1 term, and this is extra 1 term. So totally we have alpha 1 plus 1 terms of a geometric progression. So according to the formula of geometric progression, you get a into r to the power of n minus 1 by r minus 1. That formula if you use, p1 to the power of alpha 1 plus 1 minus 1 by p1 minus 1. This is the sum related to this. Similarly, p2 to the power of alpha 2 plus 1 minus 1 by p2 minus 1. So you have to repeat this procedure for each and every prime. So pk to the power of alpha k plus 1 minus 1 by pk minus 1, which gives you the sum of all the divisors, right? So this is the formula. It's better to remember, right? Whenever you want to find out some of the divisors of any number n, first you write the canonical form, then you use this formula, right? Now we will solve the question now for this number. N is equal to, what is given to you, n is equal to 2160. Just now I wrote the canonical form of this, which is 2 power 4 into 3 to the power of 3 into 5 to the power of 1. So now what is the sum of the divisors? Sum of the divisors. So what is sum of the divisors? P1 means first prime, 2 to the power of alpha 1 plus 1 means 4 plus 1 minus 1 divided by p minus 1. Then P2 is 3 to the power of alpha 2, which is 3 plus 1 minus 1 by 3 minus 1. Okay, then P3 is a prime 5 to the power of alpha 3, which is 1 plus 1 minus 1 by 5 minus 1. Okay, with the formula just now we derived, p1 to the power of alpha 1 plus 1 minus 1 by p1 minus 1 into p2 to the power of alpha 2 plus 1 minus 1 by p2 minus 1, continuation up to the ending prime, pk to the power of alpha k plus 1 minus 1 by pk minus 1. This gives you the sum of all the divisors. Now this is the calculation part only. So 2 to the power of 5, 32 minus 1, 31 divided by 1 into 3 power 4, 81 minus 1, that is 80 by 2 into 5 square 25 minus 1, 24 by 4, which gives you 31 into 40 into 4 6 are 24. So you can calculate this, right? So this is the way of finding sum of divisors, sum of all the divisors of a particular number. Just you keep in mind this formula. Now let's solve the second question. What is the second question? The number of ways of expressing n as product of two numbers. So let us suppose you have a number n and you want to write this as product of two numbers. N is equals to x into y. Now whenever you write n as product of two integers, two numbers nothing but integers only, okay? So x and y are integers, positive integers in fact. So x must be a factor of n and y must be a factor of n. Means whenever you write an integer, whenever you write a positive integer as product of two numbers, what is the meaning of this? The two numbers must be divisors of n. So now you see a simple example once again. For example, if I take once again the same number 12, which can be written as 2 square into 3, and the divisors are what? 1, 2, 3, 4, 6, and then I think 12, right? So 6 divisors we have: 1, 2, 3, 4, 6, 12. So how many ways you can express 12 as product of two numbers? Can you tell me? 1 into 12 is one way, 2 into 6 is the second way, 3 into 4 is the 12, which is the third way. Only three ways you have. Right? Now you see a simple logic in this. Whenever you want to write 12 as product of two numbers, the two numbers must be divisors, right? So for example, one of the divisor of 12 is 1. Whenever you select 1 into, something should come here. What is that? The other divisor. What is that other divisor? Is 12. Is 12, right? Now for the second divisor 2, if I take the second divisor 2, there is only one chance to fill up this place. There's only one chance to fill up this place. What is that number? 6. That number is 6. There is no other chance, right? 2 into another number, if you want to write, that is only one way possible, which is 6. Right? 2 into any another number gives you 12? No, never. So therefore, for one divisor, you will have one way to express n as product of two numbers. So 12, if you want to express as product of two numbers, if you wrote one divisor, means there is only single choice for the second number. So what is the meaning of this? For every divisor, you will have one way. For every divisor, you have one way to write the given number as a product of two numbers. For every divisor, you have one way. So the question comes, how many divisors are there? That many ways are there. So how many divisors are there? 6 divisors are there. Therefore, how many ways we should have? 6 ways. If 6 divisors are there, for each divisor you have one way, then we must have 6 ways. But if you observe carefully, there is a overcounting in this. Now, how? Let's see this. Whenever you write 12 is equal to 1 into 12, whenever you start with the divisor 2, then you are going to fill up the second place by 6. Whenever you start with 3, you are going to fill up the second place by 4. Now whenever you start with the fourth divisor 4, you are going to write 3. Means this 3 into 4, whatever the way we have, the same way, the same expression, right? 4 into 3 equal to 12, 3 into 4 equal to 12 is the same way. So this is counted 2 times. So we are counting the number of ways twice. Okay, so number of divisors you have 6, but number of ways of expressing n as a product of two numbers is half of that, 6 by 2, which is equal to 3. What is the meaning of this? The number of ways of expressing a number as a product of two numbers is number of divisors half of the number of divisors. But sometimes it is not going to work. Sometimes it is not going to work. So once again, let's see one more example. 36, if I take 2 square into 3 square. Now how many divisors are there? Can you tell me how many divisors are there? 2 plus 1 into 2 plus 1, which is equal to 9. So number of divisors are 9. So if you simply say like this, 9 by 2, what is this, right? So number of ways of expressing n as a product of two numbers is n by 2, which is not the way, right? Not the correct answer, because of 9 by 2 we are getting a fraction. Number of ways should be a positive integer. So what's happening here? Now, once you observe this, whenever you have power is even, all the powers are even in the canonical form, even plus 1 odd, even plus 1 odd, even plus 1 odd, odd, you get odd into odd. If you do, what do you get? Odd number only you will get. So we cannot make it a half. You cannot make it a half. So what is happening here? Let's try to write all the divisors of 9, then you will come to know what the changes we have to do in the formula. So what are the divisors? Now you write once. 1 we have a divisor, then we have a 2, then we have 3, then we have 4, the 9 divisors we have to write now here. 4, right? 1 2 3 4. Then we will have 6 is the divisor, then we have 9 is the divisor, then we have 12 is the divisor, then 18 is the divisor, then 36 is the divisor. Can we have do we have all? We have 9. Let's see, check once. 1 2 3 4 5 6 7 8 9. Yes, we wrote all the 9 divisors. Now whenever you write 36 as a product of two numbers, one choice is 1 into 36, second is 2 into 18, right? We are making pairs. 3 into 12, then 4 into 9. Now what happened to 6? Whenever you want to write 36 as product of two numbers, one is 6, the other is what? The other is what? No divisor left with us, right? Only 6 is there. So 6 into 6. This is the way of writing 36 as product of two numbers with 6, using 6 into 6, right? So therefore, in previous case what we have told, you can write 12 as 2 into 6 as well as 6 into 2. This is counted two times, that's why we are making it half, right? So 1 into 12, 12 into 1, 4 into 3, 3 into 4. But here 6 into 6 is only one way, only one way. So it should be counted only one time. So it is counted only one time. So we should not make it a half, right? So what we will do then? So what we do? Total divisors are 9. Then you subtract this one divisor, which is we are writing as 6 into 6 counted only one time. So 9 minus 1, which is equal to 8. Now make it half. 8 by 2, which are 4 ways, right? So 1 into 36, 2 into 18, 3 into 12, like this. So number of divisors, subtract 1, okay, divide with 2, and then you add this one way extra here, plus 1, d of n minus 1 plus by 2 plus 1. So what it gives you? D of n minus 1, it gives you now even number, make it half. Then this one way we will add extra. So if we do LCM, if you take 2 LCM, d of n minus 1 plus 2 you will get. So d of n plus 1 by 2, d of n plus 1 by 2. So this is the formula you have to use, okay? When we have to use this, if all the powers of each prime are what? Even. Now what we call, whenever all the powers of the primes are even, this will become a perfect square. You can see that 36 is 6 square, which is a perfect square. That's why here we are getting 6 into 6 only one way. Okay, so if n is a perfect square, one rule we use. If n is not a perfect square, the other rule we use. So the question is this: the number of ways of expressing n as product of two numbers, is what? D of n, number of divisors. D of n means what? Number of divisors by 2 if n is not a perfect square. If n is not a perfect square, and the same formula we use but in a different way for different case, d of n plus 1 by 2 if n is a perfect square. N is a perfect square. Now the question is very simple if you know this formula, right? So here we have n is equal to 2160. Now the question is, how many ways you can express this 2160 as product of two numbers? So first you write the canonical form: 2 power 4 into 3 power 3 into 5 power 1. Then you find first d of n. What is d of n? Number of divisors, that is 4 plus 1 into 3 plus 1 into 1 plus 1, which is what? 5, 4 is 20, 2 is 40. So number of divisors is 40. It's even. So the formula is d of n by 2. And you can see it's not a perfect square, because of when we say it's a perfect square, each and every prime has even power. Here all are not even powers, right? So therefore it's not a perfect square. If it is not a perfect square, how many ways you can write? D of n by 2. So this is d of n 40. You are getting even number means dn by 2. So d of n by 2 means 40 by 2 is equals to 20. Okay, I hope you understood this first and second question solution and how we got those two formulae, and we will discuss the remaining two questions in the video lesson, right? Thank you for watching. If you like the video, then subscribe to my channel.